Greetings and welcome to The Hidden Palace, the show where we talk with experts and enthusiasts about video game preservation. My name is Bo. I'm at the controls for another episode of the show, and I am joined by the Hidden Palace media team. We've got Saz.
Hello.
And also joining is Nick.
Hi, pals.
And we've got a special guest. We've got Alex, veteran video game developer, who is joining the show to answer our questions about his history in the game industry.
Hello.
Alex, we think your most famous credit that people might know is Resident Evil 2 on the Nintendo 64. What are some of your favorites that you worked on?
I would think Resident Evil 2 is probably up there. Yeah, I mean, it was just super exciting to try and get the game, which shipped on 2 CDs on PlayStation, and try to get it into a cartridge on the I almost said Commodore 64, N64.
That would be very impressive.
Oh yeah, maybe we should do a Commodore 64 version now that Commodore is popular again. They've just re-released a new one. So yeah, I don't know, and just the IP was super exciting because it was so wildly popular. It was the touches on the movie genre. A game like that had never been done before. And just a challenge to try and put 2 CDs into a 64 megabyte cartridge. Fun fact, there are only 2 cartridges, from what I know, that hit the 64 megabyte mark. One was Donkey Kong Country, if I remember right, and then Resident Evil 2. That's it.
Well, this is a great place to start because one of my questions I had was your credit for that, as far as I can tell, is the man. And so what did being the man on Resident Evil 2 Nintendo 64 involve?
It was super interesting. So pretty much, usually the way it worked, every person that worked on a game would get a credit for their role on the game. And that wasn't necessarily just limited to engineer, but then it was more fine granular. So for example, sound engineer or visual effects, that kind of stuff. And initially, we were only 4 engineers on the team. One engineer was responsible for kind of the operating system, if you will, because back then there wasn't like, an OS that you develop on. It was pretty much, here's the machine, here's some code, some libraries, now go. So one person was kind of responsible for whatever OS there was to make that all work with the rendering and the audio engine, that kind of stuff. Then we had another person that was responsible for the 3D rendering part of the game, like making because the rendering was a little bit different on the N64 than the PlayStation, so we had to figure out a way to basically render the same data or similar data that we had on the PlayStation on the N64. So there was a person responsible for that. Then we had one person that was responsible for the video compression algorithms. There was so we ended up compressing the backgrounds as in a JPEG format, which is why they look slightly muddier than on the PlayStation because JPEG is not lossless. And then we also had to do the video compression. So that was like a total kind of a one-off. We had access to the microcode for the N64. So that person, Todd, he created the compression algorithms that were required to play back the video and still have it, because we had to compress it hard and still have it look somewhat good. We did all kinds of tricks, like I believe we did like some kind of a tweening thing where we would render like every other scan line showing the old frame, the next one the new frame, so the low frame rate wasn't as apparent. We what else did we do? Oh, the audio. We didn't have any audio in the video itself. We actually used Factor 5's audio compression algorithm to get like a 10-to-1 audio compression. So the video had like the music and the sound effects and whatnot from the original, but the voices were all compressed using the special thing to further compress the audio. And that kind of leads into the things I did, why I ended up being in there as the man. In a nutshell, it was because they couldn't list all the things I did, so that's why I went in there as the man. But to start with, when I got there, they were using these Nintendo emulator things that ran on Silicon Graphics. Basically, I think they were like 10 grand a pop or something or more. The super expensive development kits, and we had like all these people that we needed to get development kits to. Otherwise, we'd be blocked if we had to. It's like, oh, I need to try my code, see if it runs. Oh, you gotta wait. I gotta run my code first, kind of thing. So I'm like, hey guys, why don't you just use the SN Systems dev kits, which are plugin cartridges. I knew some people that had used, or in my previous time of my career, I'd used SN Systems before. I knew they had an N64 kit. It wouldn't cost 10 grand. So we ordered one for everyone, and then everyone could develop and didn't have to wait for the silly box to be free or whatnot. So that was my first kind of foray into bringing change into the company, because they hired me specifically for that game. That was my first role at Angel Studios at the time. And then also for the audio compression, I'm pretty good friends with Chris Hülsbeck and most of the Factor 5 gang, being from Germany originally. They're from Germany. There's been a connection throughout my career. So I'm like, hey, these guys have like this audio compression algorithm. If we compress all the audio with that, we can go 10-to-1 compression at nearly lossless, and to fit all the audio in. So we went that route. And then we had the other challenge. The music on the PlayStation was all chip music, i.e. it was a MIDI file that would drive samples, and we had to somehow port that to the N64. And since I was good friends with Chris Hülsbeck, we had him ported about half of all the pieces of all the music over to the N64. I think, not 100%, but I think he didn't use the PlayStation samples. I think he recreated them, if I remember correctly. But obviously he would use the MIDI files to then get it sounding the same. And then he also trained the audio person at Angel Studios so that they could do the rest of the conversion, and he could kind of like, go back to about his business. So that was my other contribution, that whole connection. And then, so the most difficult and probably my biggest contribution was that we got like, I don't know how many scenes there were, but we got like, I don't know, hundreds of Maya or 3ds Max files. Back then 3ds Max was the thing. Capcom was using 3ds Max to create every single background was pre-rendered from 3ds Max. They modeled every single glass shard of like broken glass or whatnot. So that was just a ton of data, and they would all result into, each piece would result into one screen in the game. So that means you basically have all these 3ds Max scenes with cameras set up throughout. And I don't know how many screens were in there. I would say in the order of hundreds, maybe, or so.
Yeah, oh, definitely.
And so then how do you know, with any given camera in the 3ds Max scene, how do you know exactly which screen in the game it maps to? And never mind rendering it and all that time to create all those screens. It was like a daunting effort. And yeah, our artists, they didn't even know where to begin, basically. And then even if you think you have all the screens, you don't really know for sure, because there might be parts of the game where it's like, oh, I don't know if that's in or whatnot. So I'm like, you know what? Screw all this. Let's take the data off the production discs, off the PlayStation production discs. Well, I will figure out how the data is used. We got all the code, so I can go in there and figure out how the data is used, what screen is used where, and then I will figure out a way to convert the data back to something we can use on the N64, and we can, basically preserve the mapping by looking at the code, see how it's used, and basically do a drop-in replacement. Like anywhere there where the code would access the screen, it now accesses the screen, but it's like the screen is converted, if you will, because we had to do JPEG compression to fit it on the N64 and then just display it. But we know if we convert every single screen on the PlayStation using whatever technique I would come up with, then we know every single screen will be in the N64 version that way. And that's exactly what I did. So I set out and I basically wrote a converter, if you will, that would convert all the PlayStation Resident Evil data into something we could use on the N64 programmatically, so that there wouldn't be any chance of not having a screen in there. So that was number one. Then number two, the special effects, like there's a lot of fire and blinky lights and that kind of stuff in Resident Evil. So how do we convert all that over? And our artists, they were all asking me like, oh, should we do it? Do I need to touch these sprites to convert them and blah, blah, blah. And I'm like, no, don't touch them. Please. I will, as part of my conversion process, I will figure out a way to convert all the sprites the same way, because again, if we can programmatically figure out a way how to convert all these data pieces and we convert them all, then we know we have all the content on the N64. So I then sat down and figured out how the sprites were being used and converted all of those as well. And then we had to put all the text in, and that was quite a challenge. Then the sound driver. I think it was, if I remember right, it was a sound driver for the sound effects, and it was a similar challenge where all the sound effects had to be mapped to what the PlayStation was doing. So basically, the PlayStation had like a way of like, okay, if this weapon is held and this triggers and play the sound effect kind of thing. But it wasn't very clear just by looking at the code. Never mind that a lot of the comments were in Japanese English. So the first thing that tripped us up was like, one of the comments said, oh, the Ricker. And we were like, what is the Ricker? What the heck? And then we finally figured out, oh, it's the liquor, but they can't pronounce the L, so it's the Ricker. And that's how they wrote down all the comments. So we always had to like guess what they meant, which was interesting. But it would have been about, I would say, maybe 6 to 8 weeks or so before we were supposed to ship. And like every time when I found a bug in the sound driver where the sound effect was playing the wrong sound effect or something, I would go in and do like one-off fixes or so, just handling whatever case I was working on. And about 6 to 8 weeks or so before we were shipping, I figured out the whole thing. There was like another bug that came up. I'm like, oh my God, now I know how this whole thing is supposed to work. So I literally rewrote the whole sound driver in one night. Our lead programmer comes in the next morning and he's like, oh, dude, guess what I did last night? And he's like, what? And I'm like, I rewrote the whole sound driver. And he's like, you did what? And I'm like, yeah, now it works. And he's like, dude, we got to ship in like 6 to 8 weeks. I'm like, I know, but now it works. But you rewrote the whole thing. And I'm like, I know, trust me, it works. It was a lot of code, but it works. And sure enough, that's how we shipped it, and it did work. So that was another piece of my contribution. Oh, and then with the visual effects, like the fire and the blinky things and stuff, one little known fact, the N64 had a hardware bug where the way to properly render fire or lights or that kind of thing, you use what's called additive blending. So that means if you have like, let's say your color can go from 0 to 100% brightness. And if you're like at 60% brightness already with an object, and then you put like a light on it, the light would add to that value. So maybe the light is like 20 or 30% bright. So then you have 60% plus 30 is 90%. And now there's another light. So now you're technically at 120%, but you can't render any higher. So it usually gets clamped at like 100%. So any more light wouldn't contribute to it. You're clamped at 100%. The N64, however, did not have this clamping mechanism. So what would happen, if you get to the top of your color range, the color would roll over. And so instead of 100%, now you had 20%. So we couldn't really use the same technique that the PlayStation used, where you would just layer fire up on fire up on fire to get these bright fires that would always be contributing light to the thing. And it's like, how do you solve this? Because every time you try to overlay more and more fire or light or whatever, it would destroy, it would roll over basically. And so there's another mode where it's called a modulate mode, where you modulate the existing color with the incoming color. So instead of just adding it to it, you multiply it with it. So if you have like a 60% color and you multiply it by 80%, then it goes a little bit darker. So then all the fire would actually make things darker, and that didn't work. So the final solution was to take to still modulate it, but then to have the sprite twice as bright. So it's like the fire would be like super bright to begin with, and if you modulate it, then most of the stuff would actually get brighter. And that was then the solution to that problem. So I solved that as well. But you got to imagine, this is like for literally every single thing inside the game that had to be get this treatment. And yeah, so they couldn't figure out, one person was like OS, one person was like 3D rendering, one person was video compression, and I was everything else, basically.
Yeah, well, based on everything you described, I think the proper way to compress that into a title is The Man. So they really did a good job on that credit.
Oh, absolutely. Yeah.
Yeah, it's really impressive. Famously at the time, like Squaresoft defected from Nintendo to the PlayStation because they just did not believe they could fit those FMVs that they wanted to have for their next gen Final Fantasy game on the N64. And I think that was just the assumption everybody had at the time.
Yeah, we had no idea if it was going to work. We just set out to do it. It's like, okay, we got to make this happen somehow now. And then that's what we did.
I wanted to ask, the N64 version does have a few exclusive features. It has it has the randomizer mode.
Yep.
It has the EX scenes. Were those given by Capcom as requirements, or were some of those quality of life features things that the development team decided to do as they had time to do it?
So I think it was pretty much a collaboration. Like, what can we make unique about the N64 version? So I think ultimately it was driven by Capcom, but embraced by Angel Studios, as can be seen by the Angel Studios costume the Angel Studios leather jacket that we added. So it was mostly driven by Capcom, I would say, and we just kind of embraced it and tried to contribute as much as we could. Also, a little known fact, if you add the memory expansion to the N64, it actually renders at 4 times the resolution than the PS2 or the PlayStation. That doesn't make the backgrounds really look better because they are JPEG compressed and they're a little bit muddied. But the rendering of the characters was actually 640 by 480, unless there were enemies lurking somewhere. Because if you get too many enemies on the screen, we had to drop screen resolution because of performance reasons. So that was a giveaway. If you enter a scene and the screen resolution would drop slightly, we didn't drop it all the way to 320 by 240. We dropped it like however much we needed to. Then it's like, there are probably some zombies gonna appear soon because the screen resolution dropped, and we had to be able to handle it. So that was kind of fun too. Another fun fact to figure out as part of The Man was we had some backdrops. I don't know if you remember some of the scenes where, for example, where the dogs broke through the mirror, and I could only find a background with the mirror broken, and I was like, "What the heck? Where is the background with the mirror intact?" Oh, that reminds me. Yeah, so another thing I had to figure out was like, how does this whole 3D work? That was super interesting too. So the PlayStation 3D worked by overdrawing the sprites. So it was kind of like a painter's algorithm almost, where you would draw the background, then you would draw the character, then you would draw the table in front of it, and whatever else was in front of it kind of thing. And they would do that by, let's say that the table was just a sprite. So they would draw the background, then they would draw the character on top and the table on top, and it was a ton of overdrawing basically when that wasn't really required, because all you have to the pixels would be drawn multiple times. First, like in the worst case, in this example, they would be drawn 3 times. First the background, then the character, and then the table in front of it. The N64, it was absolutely horrible performance-wise to try and do that, which is why the N64 had a proper Z buffer, where basically it would, before it would draw a pixel, it would test, oh, am I being occluded by something else? And if that was the case, it wouldn't draw it. And that's how the N64 had to work. Now, how do you do that? Because I had to basically figure out a way, given any scene, I had to figure out which order these things would have to draw in for the N64 to not end up with a bunch of overdraw. And what I ended up doing was any static objects. So, for example, the table in the scene. The table was already on the background, but then they had a sprite table as well, so that they could occlude characters that had to appear behind the table. So even though the background had the table, they would draw the background, then the character, and then the sprite table in front of everything to make them appear behind the table, or they would draw the table first and then the character to make the character appear in front of the table. So I went in there and I analyzed, or I wrote an analyzer for each scene, which sprite was being drawn, figured out the depth information for each sprite that was part of the scene, and then I would figure out a way to generate basically a Z buffer image from all that information. And so we would only draw the background once. We would fill the Z buffer with all the objects in the scene without actually drawing the sprites. It was instead of clearing the Z buffer, I would just take whatever data I came up with based on the objects in the scene, populate the Z buffer, and then the character would automatically draw correctly against all the objects, pixel perfect, which is something the PlayStation also didn't have. That was another one of my contributions. And then going back to the mirror with the dogs, I couldn't find the scene, the background where the mirror was still intact. And those clever people, they basically drew the background with a broken mirror, and then they drew the sprite with the mirror intact on top of it to occlude the broken mirror. And then when the dogs go through, they would just turn the sprite off. And this was also like a couple months or so before we had to ship. When I discovered that, I'm like, how does this work? And so I had to, once I figured out what was going on, I'm like, oh man, now I have to change my PlayStation to N64 converter to handle this special case. Thankfully, there was only maybe 10 or 15 of these cases where they would use color information to occlude things when they wanted to change them. I think another one was where the berserker guy, I forget his name, breaks through a wall, and the whole wall breaks through. He breaks through the wall basically. Again, it was only the wall broken was there, and they would draw the whole wall again with a sprite, like a huge sprite covering the whole wall, and then they would turn it off. So there was a few cases like that I had to handle, and I just modified my converter to handle these cases. But that was another crazy thing to figure out. that did not happen overnight, but somehow we managed to do it.
I'm impressed by your recall in this. I have trouble remembering code I wrote last year, and we're 25 years plus on this.
Yeah, it was passion. That thing, it left a lasting mark on my soul and everything else. I mean, we worked like 11-hour days pretty much every day, 10-hour days for about 11 months or so. And then towards the end, obviously there were some 3 a.m.ers, but that's when I called it. I was like, no, I'm going home.
Amazing story. So, as you mentioned, this was with Angel Studios, and you had a career as an independent contract developer before that, as I understand.
Uh-huh.
And my source for this is a series of YouTube videos you did a few years ago, which I found because I was researching a very, very obscure Sega Saturn game that nobody knew about until fairly recently, called Pyramid.
Yep.
And a copy of this popped up on eBay a while ago. and nobody knew what it was. There's people who are enthusiastic about the Sega Saturn and try to keep track of what was canceled and what never got released. And nobody had ever heard of Pyramid. And so we're trying to figure this out, trying to find some sort of reference to what this might have been. And your video is the only thing. You mention it in passing in like part 4 of your video series about your time as an independent developer. And so we're very curious. We have the disc. Got it right here.
Oh, wow. I need a copy of that. Actually, can I see the disc again? I wonder if that is.
I think it's your signature, yeah.
Oh yeah, how cool. Yep. Yeah, that was interesting. I can't remember who the publisher was.
Well, so because we have the disc, we know that this is Pyramid, the Challenge of the Pharaoh's Dream.
Yes.
It's an educational title that you might have played in your school library in the 90s. And this is it, or maybe a tech demo of a scene running on the Sega Saturn.
Yes. Did you actually get it running on the Saturn?
I did, yeah.
Oh, how cool. You gotta grab a video. I want to see that. Post to YouTube, that'd be fun. Yeah, so it was basically an educational game with like 2D sprites. Something you would see in like Flash, Adobe Flash back in the day kind of thing. There was like 2 ways to go about it. One would have been to port the engine over, but I can't remember what all the holdups were. I don't remember what parts of the source code I had and how much of it was really to the point where you could just port it. But if I remember correctly, my approach was to basically develop a 2D engine on the Saturn, because the Saturn is a very cryptic beast that would basically do the same things that the PlayStation version did. Because to me, it was easy enough. There wasn't like a bunch of 3D stuff or whatnot going on to where you had to absolutely port a bunch of stuff over. So to me, the approach I took was like to create a similar engine that, it's basically like render a sprite at this position, rotate it, scale it, whatever, those kind of things, like basic operations, play this sound effect, yada yada yada, and then just take the content data from the PlayStation version and basically convert it to the engine that I was developing on, which would at the end have the same drawing commands, if you will, the same methods for drawing things, playing back sound and those kind of things, interaction triggers, that kind of stuff, as the original engine. So that was kind of the engine that I developed back then at the time, and that was a demo of the engine working with whatever data was on the PlayStation. What platform was it?
Yeah, so I was going to ask, are you breaking news here that there was also a canceled version of Pyramid for PlayStation? Because from what I can tell, it was a PC and Mac title originally.
Okay, yeah. I think I ported it from the PC version, and that and I think that's why it would have been hard to convert it or something. So I was like, I'll just write an engine that does the same thing basically.
So I'm very curious, like, how was it you got involved with this project? The publisher thought console was the way to go, and you were good at these sorts of ports, or how do you remember this starting?
So I think I have to go further back, like why I even started this business. So it was almost comical. So I got to start all the way back when I was 12, growing up in Germany. Seriously, I got my first computer, which was a TI 99 4A. Then I got a Commodore 64 a year after. That's when I decided one day I want to go to California and make video games, because I knew California was a place to make video games at. So then when I was in 89, I came to California. In 91, I started making Atari Lynx games. That was kind of like my foray into this whole thing. Then I worked on some Super Nintendo games, some of which were Super Nintendo. It was ESPN Baseball Tonight for the Super Nintendo, and that was for Sony before the PlayStation. And I mean, I worked a lot. Like 60-hour weeks were not the exception, kind of thing. And so towards the end of one of the Sony sports titles, and it was right on the cusp of when the PlayStation came out. As a matter of fact, we just got the first PlayStation kits, and I was like, PlayStation, that's never going to take off. So, and since I was working so much, I was like, I might as well start my own business. So I left Sony. I was basically employee number 2 at the time, so I would have become VP of Sony San Diego if I would have stayed. But I had a ton more fun doing my own thing, and that's how I became kind of gun for hire. And it was probably out of that at some point. I used to go to, well, back then it would have been CES. E3 was just starting. And I would try to attend gaming related trade shows and talk to publishers that I knew and people from my previous career, and that's probably how I stumbled upon this thing. And I said, "Hey guys, I've done some Saturn stuff for Sega of America as well as Sega Soft, and they just happened to not pick up their Saturn dev kit, so that was a great opportunity." After they canceled, I still had the dev kit, so I used that then to be gun for hire for Sega Saturn stuff, and that's how I picked up that project.
Interesting. So do you remember, did it get much farther than this tech demo with the single scene that we have?
No, I don't remember what happened then. I don't know if it was the traditional game cycle where publisher decides, not enough money in it, kind of. I don't remember why it ended at the end, but I remember I showed them the demo, and shortly thereafter, that was it. Basically, I was like, okay, time to find another job.
They probably saw like how well, I would say, like not so well, the Saturn was doing in America, and probably decided it was probably not worth our investment at this point.
Yeah, and even if you try to port like an educational title like that, your console audience isn't really the target audience for that kind of stuff. But yeah, I think you're right about the Saturn, because I was working with Sega Soft on a baseball game on the Saturn, and Sega Soft decided that, or was it? No, it was Sega of America. So I was working on a prototype for the World Series baseball game. So Sega of America wanted to have their own version of the baseball game, because it was done by Sega of Japan originally. And then all of a sudden they decided, it's like, oh well, let's use the Japanese version. Basically, there's no sense in developing one by Sega of America. But the work I did resonated well with some people that were at Sega of America, but then they moved over to Sega Soft when Sega Soft started, and they hired me again to do a Sega Soft baseball game on the Saturn. Why? I don't know, but basically I continued my work there with the same people under Sega Soft, and then Sega Soft was like, you know what, Saturn isn't doing so well, we'll just pull all the plugs. And that's when that permit thing came around, right around the time when the Saturn was not doing so well.
Yeah, so you can see from Saz's background, listener can't, but he's got Sonics and Dreamcasts behind him, so we come from a bit of a Sega background. So just learning that Sega of America was thinking about doing their own World Series baseball title is pretty interesting. I don't think that was well known by even hardcore fans, unless they watched your video that mentioned this.
There was another interesting bit. It was the Joe Montana football game on the Sega CD, I think. I don't know if you guys know that story.
Tell us your version.
So I think it started with John Madden football, which was originally developed by Park Place Productions. And then it was something to the effect where Sega needed a football game for the Sega CD. And take it with a grain of salt, I might have a couple things swapped here and there, but something to the effect of they wouldn't release the Sega CD unless they had a football game. And the original version of the football game of Joe Montana for Sega CD was actually better than any of the other versions. But the EA wasn't having none of that Joe Montana couldn't be better than John Madden, obviously, kind of thing. And so they had to dumb down the game before they would release it to Sega for the Sega, something to that effect. But it was almost hilarious how the stuff that goes on behind the scenes between developers and publishers is just insane.
Yeah, this is pretty interesting because one of our previous episodes we talked about this now famous Sega CD demo that has what we called Football Man, but I think is actually John Madden in this text sprite demo.
It's Joe Montana.
Oh, it's Montana.
Yeah, it's him just doing like a point at the screen, and he just fades into view, and then you see him pointing at the screen, and then he spins away in the background. It was like a Sega Multimedia Soft, had started up as like a multimedia arm of Sega of America, like to do like FMV style games, and this was like a trade show demo that they would show, and that was like Joe Montana was like one of the the features on that that multimedia demo. It was just kind of just like a scaling demo to show like, hey, we can scale and rotate sprites in real time on the Sega CD.
Yeah, funny story comes to mind along those lines. Are you guys familiar with Dick Vitale's basketball?
I'm not.
I'm not either.
That sounds familiar.
Yeah, I think it was on the, I want to say the Sega Genesis, but it was so funny. If you look closely, like the opening scene is like a bouncing basketball. You can probably Google it and look at the video of the intro scene, but the bouncing basketball that then goes through a basketball hoop. And when the basketball goes through the hoop at the bottom, when it comes out, it morphs into Dick Vitale's head because he's like a bald guy that looks almost like a basketball. If you look closely, you can see it. It's pretty funny. And that actually made it into the game. But there was also a bit of a sad story around that. I think it was that game where it was whichever Genesis, I think it was that one, had, or I think it was Sega CD because it needed some extra hardware for 3D rendering, where the game was like at least somewhat rendered in 3D. And the guy I worked with at the time, Bill Hicks, the poor guy, he was working on this thing. I remember going into the office Monday morning, and Thursday night when I was leaving, he was still in the office. Like he had been there for like 4 days in a row working on optimizing this thing. And I remember we couldn't get it any faster. He like worked so hard on this, and there was just no possible way to get this any faster. The publisher got tired of it, and they're like, oh, we'll take the whole game back. Our developers will finish it and make it run faster and blah, blah, blah. And all they did was take out all our credits, replace them with their credits. The game was not any faster, and then they published it that way. Like, so many crazy, there's a ton of crazy stories like that. It's just insane.
You mentioned in passing in your video also another unreleased Saturn game that wasn't on anybody's radar. Can you tell us anything about what Caveman Joe was?
Oh, was that for Saturn? Maybe.
I think so, yeah.
Okay, could be, yeah. That was actually one of my favorite little nugget games that I worked on. It was super cute. It was basically, let's see, it was kind of like a real-time strategy game, but in 3D. So think of like the 3D versions they had of Command and Conquer or whatnot kind of thing, where you could fly with the terrain and whatnot.
Interesting, because our assumption was that it was a port of Joe and Mac, the arcade game.
Oh, no,
like
not at all. No. It was like an isometric type view, but I think it was in 3D if I remember right, where you would have like different caveman type weapons. The one thing I was working on was like the boulder physics, because one of the things you could do is roll a boulder downhill and then squish all the cavemen that were trying to get uphill. That was like one of the things that stood out. But the game was like so appealing from a visual perspective. I think like all these cute characters and whatnot. I don't know. There was something about the art style that made it very appealing and cute and instant draw kind of thing. But
so this was a completely original IP, right?
Yes, it was an original IP by Electric Dreams / Tyke Studios. So Tyke Studios was founded from Electric Dreams. The founder, I think he works at Microsoft now. Every now and again, I still talk with him over LinkedIn or chat or whatever. I don't remember if we ever had a Saturn build. I thought I worked on the Windows build, but I could be mistaken. I don't remember. It was too long ago. I kind of vaguely remember that they had a console version in mind, but I don't know if it got to that stage or if the actual development I did was on Windows. I don't recall.
If it was an RTS game, I mean, those were pretty much only on PC at the time.
Yep. But it was fun. I remember it stood out as a great game that I think could have gone places, but unfortunately, the founder had to make money too. So I think he ended up getting a job after that.
Wow. Okay. Very interesting. We were ready to ask about the details of porting Joe and Mac over, but something completely different. Interesting. Yep. So I'm curious. If you go on the game credit sites, it seems like none of the Saturn projects you worked on ever came out, or maybe the publisher stripped out your credit. Do you remember anything ever coming out that you made?
Nope. I was haunted by the fate of the Saturn, and I was haunted by the fate of baseball game, like ESPN Baseball Tonight. I think I worked on the one that came out on Super Nintendo. I worked on one of them for PlayStation when I worked at Radical Entertainment. I think that one got canceled.
Yeah, you mentioned in your video that there was a set of 3 or 4 different components that you were tasked with stitching together.
Yes.
And was that like a typical thing? Like someone would work on the front end and somebody would work on the main game and then somebody else would glue them?
Yeah, I don't know if it was a typical approach, but I was part of the lead effort, and I was thinking, it's like, okay, if everyone works on one thing, then there's probably people going to be blocked a lot. So I was like, okay, let's get a few people work on the UI, a few people work on the 3D gameplay, and a few people work on whatever stat systems or whatever there were, and then I'll figure out how to glue all the pieces together when they're ready, basically, kind of thing. That way you can modularize the problem a little bit, and then people can work independently from one another.
Interesting. So that one never came out also?
Yeah, I don't know what happened to it. I left the company. Radical Entertainment was originally in Vancouver, Canada, and they decided to start a studio in San Francisco. It was basically this huge building right by the water. I mean, I could literally look out, and there were like there was like a drawbridge right against the building, and it would open up, and you see like a boat go by your window. It's like, oh, that's cool, kind of thing. So, but translation, super expensive, and the reason why they splurged on the office space and everything was to try and get investors. And I was thinking to myself, if I was an investor, I would run like the wind, because these guys are just bleeding money heavily. I don't know what the strategy was. I think they wanted to look impressive or whatever. I mean, I get it. Everyone has to, make a presence. But if the presence bleeds out all your money, eventually that doesn't go well. So sure enough, a year later, I was asked if I would work for free, and I'm like, no, I don't. Not really. Not my thing. I need to leave. Bye. And that's where that project went.
I see.
Yeah.
Yeah. So did you work on things at Radical Entertainment that came out? Like they had several in the 32-bit era.
No, that was it. I was only working on the baseball game, and if I had to guess, they ran out of money. Well, I mean, obviously they still kept going with their Vancouver stuff, but I think they pulled everything back to Vancouver. So I don't know if they had the bandwidth then to finish that project.
We did a little bit of digging on the Internet Archive, and we found like an old version of your consulting and contracting site where you talked about your own sort of scripting language that you had for cross-platform develop. Do you remember that and how that worked?
That was the Pyramid engine that I specifically developed for the Pyramid game. Then I thought, oh, I can use it for other stuff too.
Okay.
but nothing else was ever done with it. nobody wanted
light of day.
educational games. It's like, okay, well, that was a good experiment and good practice, but yeah, that's pretty much where that was. Then people started using Flash and whatnot, and it's like, okay, park this somewhere.
The website also mentioned that you taught some courses about game development, and how did that come about?
So actually, that's a funny story. So a guy, Ed Magnan, that I worked with at Park Place Productions, he used to teach that course, and at our local college, it was video game design, overview of the game industry, which is basically like a video game history, and video game programming class. And he did a lot of 2D Game Boy and whatnot stuff. So his class was mainly 2D centered, teaching at college. But he had to move to somewhere, I forget. But he moved out of the area, and he told the college, look, you can get somebody to take over the class with a degree and blah blah blah, or you can get somebody that knows his stuff and hire Alex for the class. And then they reached out to me and they're like, hey, do you want to teach this course? Because I don't have a degree, but I know how to, I know the stuff pretty well. So I was able to teach it. And so then he basically dropped off a stack of papers and like, here, you're in charge now. And I'm like, okay, here you go. So then I started teaching that class. It was like 2 nights a week from 6 to 9:50, I think 6 p.m. to 9:50, and I did that on top of my regular 8-hour job. So that was, but it was a lot of fun. I mean, the money was okay. I wouldn't have done it if it wasn't worth it somewhat. But it was a lot of fun to me. I mean, it definitely wasn't necessarily worth the money for the time I spent outside my regular working time, that kind of thing. But it was a lot of fun. And it was good to see the learning outcomes. Like some of my students I worked with during my career, that was kind of cool to see, and but then every now and again you get like a bad apple where you're like, oh my god, why am I still doing this? Like some people or kids would just destroy your class and you're like, oh my god, this is so annoying. but overall it was a lot of fun. But yeah, it was basically handed to me since I don't have a degree, but it was pretty successful, I think. And I changed successfully, mind you, changed the curriculum from a 2D to a 3D class, and that was a lot of fun. There are some 3D fundamentals that I believe if they teach them the linear algebra route, like going deep into all the transformations and what they do, the math behind it, and blah blah blah. And I'm like, no, that's like way too complicated. All you need to know is like transformation from this space into this space into this. The math behind it doesn't matter. You just accept it. You go from one space to another, and you have a matrix that you multiply, and boom, there you go. Much easier. And I had a lot of good luck with that, which I felt was a method that wasn't taught often. Although the way I learned it was from another friend of mine who also doesn't have a degree, and he was actually teaching 3D courses at UCSD part-time. But he once taught me that method, and that was like a huge eye-opener. I'm like, oh my god, this is actually much easier if you don't have to overthink any of this. And that's how I came up with pretty good learning outcomes when I was teaching my class, because I used the same method. I was like, oh my god, it's actually way easier. You don't need to know all the linear algebra behind it.
You're still working at Angel, or were they Rockstar San Diego by this time?
I think when I started teaching, there were already Angel Studios. Sorry, they were already Rockstar, which was the beginning of my end at that company.
Following like Resident Evil, you've got some credits on Midnight Club, Smuggler's Run, Test Drive, Off-Road, Wide Open. So a lot of PlayStation 2 stuff. That's what you were working on.
Yeah, it was GameCube stuff and PlayStation and Xbox. I worked on all of them, and then I worked on the launch title for Xbox 360, the table tennis game.
No Dreamcast, I assume.
No Dreamcast. Nope, we skipped that. Yeah, which is kind of sad. Actually, here's like an interesting fact: the Saturn was killed and large because it was so complicated to figure out, right? and the PlayStation was so easy. But then when it was PlayStation 2 and Dreamcast, the Dreamcast was easy to program, and the PlayStation 2 was hard to figure out. Yet the PlayStation 2 sold like crazy.
Yeah, the Dreamcast was just like you could just put Windows
exactly
Windows applications on it if you wanted
basically
to.
Yeah. And then even worse, when the PS3 came out, that thing was just so grotesque. It was worse than the Saturn for learning curve and how to extract the performance and stuff. And then whatever the head honcho of Sony was at the time, he goes out in public and because he was, people are like, what, WTF? Why is this so hard to program? It shouldn't be like this. You're slowing our progress. And his answer was like, well, what would you program otherwise? You got to spend your time somehow. Might as well be figuring out this. It's like, well, what about making games instead of trying to figure out this stupid thing? It was so crazy. And I remember actually, case in point, when I worked for THQ, we held, and THQ was porting or making I think it was a port of Darksiders to the PlayStation 3, and they couldn't figure out how to bring up whatever they needed to on the PlayStation 3. So I was working at a THQ Carlsbad studio at the time, which is by San Diego, and they flew us in to bring up the port for the PlayStation 3. So we spent about 3 months bringing up the PS3 game on the PS3 because they couldn't figure it out, and we didn't get any credit for it. Like, none of us, like, as if they did the whole thing. And it's like, seriously. But that's so much for the PS3. It was so hard to figure out that at least in the beginning, there weren't that many people that could figure it out, I guess. But yeah, another tragic story of no game credit.
Yeah, I remember the PS3 when it was first announced being like kind of like ridiculed a little bit, but like even like right during its launch era. I was at E3 2006, and the only games that crashed on the show floor were PS3 games. And they had to like open up these cabinets, and there were just these giant racks of the PS3 development kits that were just these massive boxes just to reset the games. So the fact that those were the only games that were crashing on the E3 show floor kind of shows how difficult it was at the time to develop for it.
Was that the giant like lunar lander looking type giant metal shiny boxes that you saw?
Yeah. It was E306. So like the console had like just been announced. Like it wouldn't come out for like another like 8 months at least.
Funny story behind that, because at Angels or Rocks, I think it was Rockstar at the time, we had one of those boxes at work, like one of those boxes, because crazy expensive and rare, blah blah blah. And then we moved offices within, it was like maybe, I don't know, half a mile to a mile or so away from the old office, and that thing disappeared. It was like, oh wow, where'd this box go? And I can't remember what the story was, but I remember it was missing for a few days, and then it turned up somewhere. But it's like, how does it go? A box this big and this important, how does it go missing? Like, why don't you like treat it like Fort Knox? Somebody puts it in their car, the car is being watched by other cars, and you shuttle it over. The thing disappeared. What the heck?
Probably if it was not there, development would stop, right? You would not be able to.
Oh yeah, we would have been screwed.
Yeah.
Yep.
So this leads to something I was curious about. So when a new system was coming out, or when you were working on something that you hadn't worked on before, were the game companies, were Sega, Sony, etc., like educating you? They just ship you a bunch of manuals and you figure it out? Like, what was the process of getting going on a PlayStation 3 or PlayStation 2 or even in N64?
So I actually have a specific PlayStation 2 example for that. Usually you get a bunch of libraries, a little bit of demo code, and then some documentation and then you have to figure it out, kind of thing. And then they have support, but it's pretty much, you had to know your stuff to try and dig in and figure things out. But I specifically remember for the PlayStation 2, I had that famous billiard demo, which I don't know if you're aware of it, but the developers got like this billiards demo, which is like billiards balls knocking around kind of thing in 3D. And it's like whoop de doo. But I didn't have the for some reason whoever was in charge of the development kids at the studio they forgot to give me some library headers and some other documentation or whatnot that was basically putting there were DMA lists, like direct memory access or whatever, like DMA transfer lists. So the way it worked is basically you had like these DMA lists that were stitched together, which was basically a string of polygons, for the lack of a better term, a string of polygon lists that would be sent to the rendering engine that would draw them then. And there was a specific way that these lists had to be pieced together. And I didn't find out until 6 months down the road or so that Sony actually had like these helper libraries that would help you stitch these DMA lists together. And I was wondering when I first got the kit, I'm like, okay, well, I was looking at the code. I'm like, okay, they're somehow putting these DMA lists together, but it's kind of a pain in the ass to put them together. There's got to be a better way to do this. So I myself sat down and figured out clever ways on how to put these lists together. And I wrote my own little helper, header, libraries, whatever, blah, 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 to put these DMA lists together. And about 6 months later, when I finally had stuff going on the PlayStation 2, somebody is like, oh yeah, by the way, there's like this other stuff you can use. And I'm like, what? Where was this 6 months ago? And I was looking at it, and Sony's own whatever helpers there were actually much harder to use than what I came up with in 6 months. I'm like, screw that, I'll just keep using my own stuff. I don't need this anymore. 6 months too late, screw it, whatever. And so yeah, I just rolled with what I had. That was kind of a fun story. So yeah, there's a lot of figuring out stuff to do, but that's something I enjoy. Like if I'm not challenged, I'm bored, kind of thing. And therefore most of the challenges are when I encounter new things that I have to learn. And then that's really what drives me when I have to get into the guts of things and make hardware do things that it's not supposed to do. There was a fun example on the Xbox 360, I believe, on the I think it was for the table tennis game. I was trying to do some special effect that required that was based on the depth buffer, basically. So you have a color buffer which stores your visual data, and then you have a depth buffer that's used for sorting the different items in the scene so that they draw properly front to back, kind of thing, like things are occluded properly. And then there's special effects that can be driven using the color buffer, the visual stuff, but some special effects like depth blur, for example, like the further stuff is away, then you want to blur it more. So there's special effects that use that depth buffer basically to then apply special effects. So stuff that's far away gets blurred out, stuff that's closer is more visible to kind of simulate a camera. But the problem was that to optimize for performance, you would want to scale down the buffer. So because you don't want to run a special effect based on the full screen image, it's like too high res, too much data to churn through. So trick was to lower the size of the image basically before you run your effect. And the Xbox had texture scaling, obviously, for the color buffers, for the visual data, so you could scale sprites or textures or what have you. But they didn't have anything for the depth buffer. So if I wanted to run that effect, I had to run the effect on the full screen image. And I'm like, well, how do I take the depth buffer and turn it into a smaller depth buffer so I can run my effect on it? And the hardware, and this is where I'm getting at with using hardware what it's not supposed to do, because there was no thing that said like, oh, take this depth buffer and make it smaller. That was not supported by the hardware. So I'm like, screw that, it's not supported. I'll figure out how the hardware works. And then I looked at, okay, the color buffer and the depth buffer, they have this different magic entry. So I changed that magic entry so that the system thought, oh, this is not a depth buffer, it's a color buffer. And then I used the hardware to scale it down, and then I changed that magic value back so it thinks it's a depth buffer, and boom, it worked. Now I had a depth buffer that was scaled down by the hardware, even though the hardware officially didn't support it. So it was those kind of crazy deep dives that I love doing, and just like messing and hacking until something works, kind of thing.
I do have a specific question related to your credits. There is something specific to a couple of PS2 games. It's water microcode. Especially around this time is when the water graphics was starting to ramp up for many just visual arts overall, especially for games. What would you describe that work like, especially since you were essentially pioneering your own programs to do such work?
Yeah, that was on the GameCube. That was super fun. So there was Transworld Surf for the Xbox. I think it was Xbox One at the time, and I think Xbox One already supported shaders in some form. So whatever water effects they had there were based on shaders, to whereas the GameCube only had a fixed function pipeline. And I'm going to see if I can, and I basically had to implement the same water effects that were available on the Xbox. I had to implement them using the GameCube's fixed function pipeline kind of thing. And I'm going to try and explain it the best I can. So let's see. I think the easiest one to understand is what's called the Fresnel effect. The Fresnel effect on water, I don't know if you ever noticed, but if you look straight onto water, it's more or less transparent. But then if you glance over water, like a lake or whatever, it turns almost into a mirror. So there's basically a function that says, okay, depending on the angle that you look at water at, it goes from a mirror to transparent. Like the more you look onto the water, the more transparent it becomes, basically. And you can model that perfectly with like a dot product, basically, between the water surface, the angle of the water surface, and the look angle. So the more acute the look angle, the more acute the look angle is, the more mirror-like it becomes, and the more you look onto it, the more see-through. And so that's a fairly simple thing to do in a shader. You just say, whatever the texture that you make it more or less opaque based on the dot product, which is basically like, okay, how much of opacity should I give it based on how acute or perpendicular the look angle is relative to the water. And so I had to figure out how to do that in the GameCube, but I didn't have shaders. I had this fixed function pipeline, which is basically it would give you things like a look angle. You could get the look angle relative to a surface, for example, and then you could say, okay, I can use this look angle and translate it into a lookup of a texture. So I can say if I look at the water straight on, it will pick the pixel in the center of the texture. If I look at it, depending, from north, south, west, or east, relatively at an angle to the water, then it'll pick one of the corners of that same texture. Like the more I glance at the water, the more the pixel pickup will go towards an edge or an edge of the texture. So if I look at it at an extreme angle from north, it will pick the top pixel of that texture. If I look at it from east, it will take the right pixel of the texture, etc., kind of thing. So you could bind the look angle to a pixel position on that texture. And what I did is I took that texture and I made it more and more opaque towards the edges, and more and more or less opaque towards the center. So the center pixel was perfectly clear, and it would get more and more opaque the more you strayed away from that center pixel, so that it would map basically to the look angle of your surface. So if you look at the water straight on, it would pick the pixel in the center, which was not opaque at all. And the more you would deviate from that, the more opaque pixels you would pick up. And then you use that as a multiplier, basically, how much of the reflection should I apply to the water, which was basically just a simple lookup into this texture based on the look vector. So that's how you would express the same shader expression of a dot product with a GameCube, which was an interesting feature. It had advantages and disadvantages. The disadvantage was it was obviously less flexible. You could only do certain things with it, like what I just described. But the advantage was it was a lot faster. The hardware could do this a lot faster as a fixed function pipeline than the shader could on the Xbox. So while it was more limited, the performance, if you compare apples and apples, would be a lot faster than with the Xbox. I mean, obviously, they maximized both to where they would look very similar at the end of the day. But if you bunch a lot of these fixed function things together, like just as a demonstration, like, oh, the GameCube can actually do this faster, then there would probably be cases that you could construct that would actually run faster on the GameCube than on the Xbox, and vice versa. The Xbox, you can construct more complicated combining of to achieve an effect that you wouldn't be able to replicate on the GameCube then.
We will try to dig up a video of Transworld Surf in action and link it in the show notes so people can see what this looked like in motion.
I think I just dumped a prototype of Transworld Surf on. I think it's the PlayStation version.
It came out on all three platforms, I think.
Yes,
maybe in successive years.
Oh yeah, I did. I remember I did the PlayStation version microcode. That's so it's funny because the people that gave credits, they weren't sometimes so sure what we were actually doing. Because on the GameCube, it was not microcode. It was this fixed function pipeline thing. But on the PlayStation 2, it was actually microcode. And that was challenging too, because let's see. So the PlayStation 2 didn't have perspective correction, if I remember right. There was like something funky about the way that the triangles were rendered with respect to the texture mapping that the Xbox got perfect. And so the Xbox made use of a lot of that kind of stuff. So I had to come up with some clever solutions so that you wouldn't. I don't know if you remember, it might have been PlayStation 1. PlayStation 2, there was probably ways around it. But there was like definitely differences in rendering between Xbox and PlayStation 2, where the PlayStation 2 looked a little bit rougher than the Xbox when it came to like texture mapping and that kind of stuff.
PlayStation 2 famously is jaggy on visually.
To Nick's point, I mean, it definitely was around that time. People, well, I mean, I guess throughout the years, people have been trying to get realistic water effects in video games. I mean, they've been the subject of endless tech demos for decades now. So I think definitely around the early 2000s, as shaders started being like more commonplace, we were actually able to start seeing those tech demos actually be used in real time, like gaming, in real time games in around that era. So it's definitely impressive what work you had to do just to get parity between different consoles at the time.
Yeah, and it's actually super interesting because if you I mean the PlayStation 2 and the GameCube versions, they came close to the Xbox version, but still the Xbox version is just amazing. If you really look close, you look at the foam, you look at the sun making the water glow, all those, there's a lot of details in the Xbox version that to this day, good luck finding a single other surf game that has better water than the Xbox version of Transworld Surf. Look at the details. I can almost guarantee that there's not one that looks better, other than resolution, obviously, that kind of thing. But the actual rendering of that wave on the Xbox was just absolutely gorgeous, I think.
Is your sense that the interesting differences between platforms got less and less over time, or did it maintain sort of that way longer than I'm thinking?
So I think that's a good question. I think the perspectives changed a little bit, maybe because with the older platforms, you had to be really good as a programmer to even make it do what you wanted it to do. But then on top of that, you also had to have a good vision and idea of what you wanted the final thing to look like in the first place. So, for example, going back to the wave problem, the vision and the target that they were shooting for was already very good to begin with, to where they knew exactly how, what would affect lighting of a wave, like the different factors that go into rendering a wave. To them, it was they studied this. They used to read books on how to render water and foam and all this stuff. It was already very well described in other ways, but then to translate that onto a platform that is very limited, that is a second challenge. So the first challenge is to understand the problem and decompose it, and being able to replicate it in a simulation fashion. And then the second problem is the platform, if it's limited. So then, to answer your question, to fast forward, nowadays it's much less of a problem of the limitation of the platform, but much more of the problem: how much does the programmer or the person that implements this thing understand what it takes to render a wave realistically? The nuances that go into it are mind-boggling, and I was I remember being super impressed by the look of the Xbox version.
And when you started doing games, even the early TI ones, you're doing custom assembly code for each machine, right? And then at some point, games start being written in C, and then later they start having engines that can supposedly run stuff cross-platform. How was that transition for you? Was it, I'm programming for a new system, so now I have to learn MIPS or something? Or were you writing something and then adapting it?
So I really enjoyed assembly language, machine language, whatever. My foray into the professional game development was on the Atari Lynx, which was on a 65 CO2, and then it was that similar chip on the Super Nintendo, and then we started switching to just C code, where we shared code between the Super Nintendo and the Genesis. So like some of the ESPN National Hockey Night logic was actually written in C and then compiled for the Super Nintendo and the Genesis. That was a very early thing. But then as we go forward in hardware, I found that I could write code much, much faster over time, and being able to get so much more done as the languages developed and the engines and whatnot. So I enjoyed the transition, not necessarily from a problem solving point of view, but rather I can get so much more done, and therefore I can solve much bigger problems because I can get so much more done with these languages that facilitate expressing what my intent in code.
I think the issue comes when you're using like a cross-platform library. Like I've heard horror stories of developers who've used renderware like in its early days, and having to still come up with console-specific hacks for like PlayStation 2, where renderware just does not run well at all. So I mean, it's like a trade-off to have like a lot of these ease of access tools that does make your life easier in some aspects, but it can trip you up in other ways.
Yeah, I think they're disappearing more and more, those nuisances between platforms. Case in point, one thing I found absolutely amazing was when I was working for Roblox the last 4 years. That engine runs on Android, iOS, Macintosh, PC, Xbox, PlayStation, and VR. You build a game on it. You press the publish button. It comes within 1 second. It's out on all those platforms simultaneously, and you can play cross-platform between all of them. Now, having said that, yes, there are limitations, but I think even when I was working there, we solved a lot of those limitations to where it's gone far from the blocky characters that they were at first. They have like Call of Duty clones on Roblox, and you can play it on your phone, even on your crappy mid-range phone, and it runs fine against someone that plays on the MetaQuest, against someone that plays on their PlayStation. What other engine do you have where you can do that, right? So, and plus there's like 150 million daily active users on the platform. So you have an instant market. So I think the give and takes, are the performance give and takes are more and more disappearing as time progresses, I think.
By the way, I dug up the Trans World Surf build.
Nice.
Got that Infogrames logo on it.
Yep. Very cool. Brings back memories, good and bad.
All right, so I think we're nearing toward the end of our time here. This has been so much fun. Thanks for
thanks for having me.
sharing all these stories. Any parting thoughts or questions we want to get out before we leave?
Let's see. So I left the games industry for the third time now to literally build cars. I got a job at GM. So I think if people are listening and they got their heart set on getting into games, open up your mind more. If you're a programmer, there are lots of fun jobs, even outside games, like building a car computer is kind of fun, which is what I'm working on now. Cars need UIs. So if you're a UI artist, you can, cars need UIs. Other things, other industries like airplanes, they need UIs, they need computers, that kind of stuff. I was very much set on games, but I think you can enjoy your career even outside games. So that would probably be my biggest advice to people where the heart set is on making games. There's a lot of similar disciplines in other industries where if you can find a job in games, go do something else, and maybe in the future you'll make games, or maybe you'll find games is not your calling. I think that was a very big eye-opener for me. It's like, hey, games is not everything. There's actually a lot of fun jobs outside games.
Thank you to Alex for joining us for this episode. And join us again. We will be back with another recording at some point in the future. You know what to do with podcasts. Tell your friends about it. Maybe you could rate it. Maybe you could subscribe to it. Thanks again for listening.